on gas meters under Legal Metrology Act 2009 and the implementation plan of the same. And I would also like to welcome Shri Bal Mukund Vyas ji, Chief Scientific Officer, Yadav Measurements Private Limited, who would be giving a discourse on differences in the current Indian Standard IS 14439 Part 2, 1998, and the new draft Indian Standard on the gas meter, which is on the anvil. And my welcome to Shri Kaushik Patandi, Chief Manager, Head Marketing, Gas Development, Genius Power Infrastructures Limited, and who would be giving his presentation on the types of diaphragm gas meters and advantages of diaphragm gas meters over other types of meters. And I would also like to welcome Shri Patranjan Bhattacharjee, strategic business development that he handles in Secure Meters Limited, and he would be giving a presentation on expectations from metering, regulatory alignment and guidance. And Shri C.V. Suresh Saab, Chief Research Engineer and Head, Air and Gas Flow Laboratories, Fluid Control Research Institute. A special welcome to Suresh Saab also to this event, who would be speaking on the subject of testing infrastructure in India for domestic gas meters. My own colleague, Shri Rajiv Ranjan Singh, Head of the Production and General Engineering Department, Kundan Giri, Member Secretary of PGD 26, the BIS Technical Committee on Weights and Measures, and all the participants. There are more than 120 participants currently, and the number is increasing. I welcome all of them to this very important event that BIS is organizing. In fact, BIS, it may be some 75th or 80th or maybe 100th event. We are on awareness and implementation of Indian standard. It is very important to make an Indian standard, but we are also we have the responsibility to see that it is actually implemented. For that, there is a need to make the masses aware, at least the current concerned immediate stakeholders aware about that the standard has been brought out, standard is available, and initiate them into the contents of the standard, the basic important requirements of the standard. And this we have seen over a last many decades that such kind of interactive measures have helped in improving it. It breaks the ice. People become more comfortable because standards are ultimately highly technical documents. So there is a hesitation on the part of the users, to open the publication, read it. They say it is very drab and boring. So it is very important if we give interesting presentations and they become more interested, and therefore our purpose of making the standard is fulfilled. We get better feedback from the stakeholders. If they understand better, your feedback and contribution would also improve. In that series, this is one of the seminars, awareness implementation that we are holding. And my congratulations therefore to our production and general engineering department for selecting the right topic. And natural gas, as you have said, India has embarked upon alternate energy sources, and we are slowly decreasing our dependence on conventional sources of energy, particularly fossil fuel based. And in this regard, this is one of the very efficient fuels which can supplement the other measures. Dependence on coal-based energy would also reduce. The PNG is supposed to be, piped natural gas is supposed to be more, and there are more and more households who are being connected to PNG, and it is safer, being lighter. In the event of any leakages, it is economical, it is convenient to use also. Therefore, we can easily understand that in future this demand would increase, and therefore the standard should provide the required backup, for ensuring that the measurability and the reliability of pricing and accuracy of measurements are taken care of. And therefore domestic gas meters would continue to play a very important role. As already mentioned by Mr. Rajiv Ranjan, BIS has formulated IS 14439 Part 2, 1998, diaphragm type gas meters with maximum operating pressure of 0.5 bar. These standards provide the requirements for functionality, safety, reliability, help in fair pricing. It helps in industrial development by providing guidance to the manufacturers. It also serves the purpose of consumer protection and customer satisfaction, and therefore these standards are very important to understand and implement. In fact, not only these, all standards are dynamic in documents. They are subject to the regular reviews and systematic periodic reviews also, and there is therefore scope for improvement, absorbing the improvement, and therefore through amendments, through revisions, and all are welcome to contribute through suggestions and feedback. Standards are not static in nature, therefore nobody should feel that if something has come in the standard, it cannot be changed. So as our understanding of the subject improves, the technological developments happen, standards are bound to change. And all standards since 1947, when the BIS came into being, have been formulated and revised number of times. And the revision also signifies that standard is being used, and based on the use we get a lot of feedback. And this, like information about availability of standards, I would request all the 120 odd participants and my fellow speakers here should spread. All of you are the extended arms of BIS, and BIS alone would not be able to know. Our country is so vast that would not be able to do the required job of awareness implementation. Therefore, all of you who may be part of the committee or otherwise are actually part of BIS. You are all extended arms of BIS and should circulate all this information widely, and to ensure better awareness and implementation. And there is a BIS certification also on the all the products are amenable to BIS certification against these standards. So which ensures that as a part of quality culture, the certified and conforming product is made available to people at large. So we should ensure that standard is well prepared, well documented, comprehensively covers all the provision, and is certifiable. And once certified, it serves the intended purpose. With that, I once again congratulate all of you who are participating for being part of this event, and look forward to your suggestions and contribution and better understanding of the subject matter. Thank you so much.
Thank you very much, sir. And with your blessings, we will now move on to the technical session. Our technical session will feature some of the best minds in the industry who will share their knowledge and insight on various aspects of domestic gas meters. Each presentation will be around 20 minutes long, and we will remind the speakers when the time is almost up. So during the presentation, the attendees can write their questions in the chat box, and we will take them up during the question and answer sessions. Some of the very interesting questions we can take immediately after the lecture also. So now I will introduce our first speaker, who is Shri Manoj Kumar Nayak, Deputy Director Legal Metrology, Department of Consumer Affairs. He will talk about draft regulations on gas meters under Legal Metrology Act 2009 and the implementation plan. So, sir has joined services in the year 2004 as a meteorological assistant at RRSL Bhubaneswar, and he worked as assistant director of legal metrology at RRSL Ahmedabad from 2010 to 17, and he worked as deputy director legal metrology at RRSL Guwahati from 2018 till 2021, and he is now deputy director legal metrology in the Department of Consumer Affairs, Krishi Bhavan, New Delhi. He specializes in legal metrology for verification of legal standards.
Namaskar.
Yes, sir. So now I request sir to kindly share his presentation and start his talk. Yes.
Should I start the presentation?
Yes, sir. You can share your presentation.
Yes, sir. Just a minute. Yes, sir. Yes, sir. Namaskar, and this is the presentation of gas meter regarding proposed draft rule for gas meter, which is to be included in the 8th schedule of legal metrology general rules. And under section 52 of the Legal Metrology Act 2009, it deals about the power of central government to make rules. And under section 52 clause deals about the metrological controls such as physical characteristic, configuration, constructional details, materials, equipment, performance, tolerance, period of re-verification, method or procedure of test, and the central government can make the rules. And it is proposed on the basis of OIML recommendation number R137, part 1 and part 2, in addition 2012, and this is proposed draft rules for the gas meter. And gas meter is an instrument intended to measure, memorize and display the quantity of gas passing the flow sensor. And gas meter, it is propane and natural gas, the quantity or pressurized quantity of gas that flows via the meter. Gas meters measures a defined volume, temperature under certain temperature, pressure through a meter. The quantity of gas can be expressed in units of volume or mass. And this recommendation applies to gas meters intended to measure quantities of gaseous fuels or other gases. And it is not cover meters used for gas in the liquefied state, multi-phase, steam and compressed natural gas used in CNG dispenser. And the gas meters, various types of gas meters are there. That is volumetric flow rate of gas measured using a range of gas meters, and that are diaphragm meters, rotary displacement meters, velocity type gas meters, head type gas meters, thermal type gas meters, acoustic gas meters. I think some of the paper presenters are from the manufacturing unit, and as I heard, they will elaborate about the diaphragm meter. And diaphragm principle of operation of gas meter. So number one, diaphragm meter. These gas meters have 4 measurement chambers linked together to form a unit that is separated by diaphragm and a deformable wall. And diaphragms are connected by a rotating piston and can also be employed with pulse generators for providing a meter reading. And diaphragm meters are mainly installed in domestic applications because they have especially large range ability. That is maximum flow rate and minimum flow rate, that is ratio is 160. And rotatory displacement meter consists of 2 rotating impellers that move opposite to one another. The impellers are placed inside a housing. The gas volumes can be measured directly since the volume of each measurement chamber is well known. Rotary displacement meters can also be achieve high range abilities like diaphragm meters, and the ratio of maximum to minimum might be goes up to 250. The error curve of rotatory displacement meter is determined by the losses between the impellers as well as between the impellers and housing.
Nayak sir, excuse me. You can just put your presentation in slides, so it is not full screen. You can put it in slides.
Okay, sir.
Yes, okay, thank you.
The calibration of gas meter should be in good operational condition during usage and should possess a valid calibration certificate. it is necessary to perform periodic calibration of gas meters to avoid generating significant errors. The common calibration practice involves setting a short recalibration period for the new gas meters, then performing sequential calibration. Drift between each calibration to be estimated, and users can be determine whether to increase or decrease the calibration interval. And uses of gas meter, they are used in offshore and onshore drilling rigs to detect the measure gas quantities. They can be retrofitted to existing rig flare lines to measure the gas volumes. Gas meters are no exception. Gas meters must be in good operational condition and must have a valid calibration certificate. And they are used residential, commercial, and industrial buildings that consume fuel gas supplied by a gas utility. And international practice with gas meter, the initial re-verification period diaphragm type, it is 7 years proposed. For the meters rated air capacity greater than 250 cubic feet per hour, that is 6.8 meter cube per hour. Initial verification period is proposed at 7 years, and for the subsequent re-verification period, it was 6 years in the international practice. And after subsequent re-verification period after 2014, it is reduced to 5 years. And meters rated with air capacity less than 240 cubic feet per hour, that is 6.8 meter cube per hour, qualifying under clause was 10 years, and initial verification was 7 years, but after 13 it is made 6 years, and subsequent verification it is made 8 years. Rotary type gas meters, which is subtype or node pressure body type, that is initial verification period is 20 years, and after 2013 it was made 17 years, and after 14 it was made 16 years. So like that, rotary, turbine, orifice, ultrasonics, fluidic oscillation, vortex, all meters have been almost came to after 14. It is periodic re-verification period is made almost 4 years. And I will show the later on the gas meter which was approved by the Ministry of Consumer Affairs on the basis of international recommendation only, not in the testing inside the country. And in the provisions relating to approval of model in accordance with Legal Metrology Act, under Section 22, every person before manufacturing or importing any weight or measure shall seek the approval of models of such weight or measure in such manner on payment of such fees and from such authority as may be prescribed, provided that such approval of model may not be required in respect of any cast iron, brass, bullion, or carat weight or any beam scale length measure not being measuring tape, which are ordinarily used in retail trade for measuring textile or timber, capacity measure not exceeding 20 liter in capacity, which are ordinarily used in retail trade for measuring kerosene, milk, or potable liquors. Provided further that the prescribed authority may, if he is satisfied that the model of any weight or measure which has been approved in a country outside India conforms to the standards established by or under this act, approve such model without any test or after such test as he may deem fit. This is the act under Section 22. The director is empowered for model approval. So in the technical specification, we have two parts are there. Part 1 deals with the metallurgical and technical requirements, and part 2 deals with the metallurgical controls and performance test. And some technical terms are there, that is flow rate, % of the actual quantity of gas passing through the gas meter and the time taken for the quantity to pass through the gas meter. This is flow rate Q. And maximum flow rate, Q maximum, it is the highest flow rate, and minimum flow rate, it is the minimum flow rate. And transitional flow rate, it is denoted by QT. It is and flow rate which occurs between the maximum flow rate, that is Q max, and the minimum flow rate, Q minimum, that divides the flow rate ranges into two zones, the upper zone and the lower zone, each characterized by its own maximum permissible error. So upper zone has the own maximum permissible error, and the lower zone also has own maximum permissible error. And test condition, the metrological requirements, rated operating conditions, values of Q max and QT and Q minimum. The manufacturer of the gas meter should mention the rated operating conditions. The flow rate characteristics of a gas meter shall be defined by the values of Q maximum, QT and Q minimum. And there are ratios and relations shall be within the ranges as stated in the table 1. Q maximum divided by Q minimum, the ratios greater than 50, then Q maximum and QT ratio should be greater than equal to 10. And whenever the Q maximum and Q minimum ratio is greater than 5 and less than 50, the Q maximum and QT should be greater than equal to 5. In accuracy class and maximum permissible errors, gas meters may be divided into three accuracy classes, that is 0.5, 1 and 1.5. A gas meter shall be classified according to its accuracy in one of these classes. The value of the MP is dependent on the applicable accuracy class as listed in table 2. That is, it is based on the flow rate Q. When Q minimum is less than Q is less than QT, the accuracy maximum. First, during the type evaluation and initial verification, error for accuracy class 0.5 is plus minus 1%, and for accuracy class 1, it is plus minus 2%, and for accuracy class 1.5, it is plus minus 3%. It is during the evaluation and the initial verification. And when the Q transitional flow rate is less than equal to flow rate Q is less than equal to maximum flow rate, for accuracy class 0.5, the initial maximum permissible error is plus minus 0.5%, and for class 1 instrument it is plus minus 1%, and for class 1.5 it is plus minus 1.5%. And during the subsequent verification and in service, that is in service, the accuracy class 0.15, the maximum permissible is plus minus 2%, for accuracy class 1 plus minus 4%, and for 1.5 accuracy class this is plus minus 6%. So in service condition, the maximum permissible is almost double the first initial verification. And another term is weighted mean error, WME. The weighted mean error shall be within the values as per the table 3, and flow rate flow rate Q and accuracy class 0.05, it is for the evaluation and initial verification, WME should be plus minus 0.2%, and for class 1 accuracy it is plus minus 0.4%, and for 1.5 accuracy class it is 0.6%. And a gas meter shall meet the following requirements after being subjected to flow with rate between 0.8 maximum and 0.2 Q maximum, comprising a quantity that is equivalent to a flow at Q maximum during a period of 2000 hours. This is the durability condition. It should require the flow rates from QT up to Q maximum, a fault of less than or equal to 1.5 times the maximum permissible error applicable during the type evaluation for class 1.5 or 0.5. And the part two, the technical specification covers the metrological controls and performance test. And this recommendation applies to gas meter based on any measurement technology or principle that is used to measure the quantity of gas that has passed through the meter at operating condition. And recommendation applies to gas meters intended to measure quantities of gaseous fuels or other gases. It does not cover meters used for gases in the liquefied state, multi-phase, steam, and compressed natural gas used in CNG dispenser. A metrological controls general procedure is there in the details. It will be not some of the performance test I will talk about. The dry static temperature test. It is the standard applicable is IC 6006822 and object of the test is verification of compliance under the conditions of high environmental temperature. Test procedure in brief, the test comprises of exposure to the specified high temperature under free air conditions for the time specified. The time specified is the time after the UT has reached temperature stability. The change of temperature shall not exceed 1 degree centigrade per minute during the heating up and cooling down. The absolute humidity of the test atmosphere shall not exceed 20 gram per meter cube. When the testing is performed at temperature lower than the 35 degree centigrade, the relative humidity shall not exceed 50%. And temperature upper limit is specified in degree centigrade, duration is 2 hours. In cold influence test, the applicable standards is IC 6006821 and object of test verification of compliance under conditions of high environmental temperature. The test procedure in brief is the test comprises of exposure to the specific low temperature under free air conditions for the time specified. That means the time specified is the time after the UT has reached max temperature stability. The change of temperature shall not exceed 1 degree per minute during the heating up and cooling down. IC specifies the power to the UT shall switched off before the temporary rate. Duration is 2 hours. Dam feed steady test state non-condensing influence test and applicable standards is IEC 60068-278. Object of the test verification of compliance under conditions of high environmental humidity and constant temperature. Test procedure in brief, the test comprises exposure to the specified temperature and the specified constant relative humidity for a certain fixed period of time. The UT shall be handled such that no condensation of water occurs on it. The gas meter shall be subjected 3 times to an accuracy test at reference condition before the increase of temperature, at the end of upper temperature phase, and at the reference condition 24 hours after the decrease of temperature. Relative humidity would be 93% and duration 4 days. Vibration disturbance test applicable standard is IEC 60068-247 and object of this vibration test is verification of compliance under condition of random vibration. And the test procedure is the test comprises exposure to the level of vibration for the time specified. The UT cell subsequently be tested in 3 mutually perpendicular axes mounted on a rigid fixture by its normal mounting means. The UT shall normally be mounted in such a way that the gravity vector points in the same direction as it would do in normal use, where based on the metering principle, the effect of gravitational force can be assumed negligible. The UT may be mounted in any position. For example, the diaphragm gas meter always has to be tested in an upright position for each direction in which the meter has to be tested. During the test, the instrument is not required to be powered off, that is always switched on. And the frequency range is 10 Hz to 150 Hz and total RMS level 7 meter per second square and number of axes is 3 and duration for axis is 2 minutes. Mechanical shop, this is disturbance test and applicable standard is ISC 60068 2/31. And the object of the test is verification of compliance under condition of mechanical shocks. The test procedure in brief is the UT placed it in its normal position of use on a rigid surface. It tilts towards one bottoming edge and is then allowed to fall freely onto the test surface. The height of fall is the distance between the opposite edge and the test surface. However, the angle made the bottom and the test surface shall not exceed 30 degrees. During the test, the instrument is not powered up. It is always to be kept on switched on. And the height of fall is 15 mm and number of falls each bottom edge is number 1. And performance test, that is electrical in general, it is radiated RF electromagnetic field disturbance test and the applicable standard EISC 606100043 and the object of the test is verification of compliance of the UT while being exposed to RF electromagnetic fields. And the test procedure is for the UT is exposed to electromagnetic field having the required field strength level specified and the field of uniformity is defined in the referred standard. The referred standard, the UT shall exposed to the mounted wall field frequency. The frequency shift shall be performed only pausing the adjust the RF signal level or to show stepwise shall not exceed 1% in the preceding frequency value, 1% of the preceding frequency value. The dwell time of the amplitude modulated carrier at each frequency will not be less than the time necessary for the UT to exercise and to respond, but shall in no case be less than 0.5 seconds. The expected most critical frequencies, that means clock frequencies, shall be analyzed separately and the frequency range should be 80 megahertz to 3 megahertz and 26 megahertz to 3 hertz. And in electrostatic
Please
discharge.
conclude. Sir, please conclude.
Okay, sir. And for offense and penalties, the section 25 Act penalty for use of non-standard weighter measure. The first offense is for fine up to 25,000 and for the subsequent offense imprisonment of for a term which may extend to 6 months and also with fine. And penalty for manufacture or sale of non-standard weighter measure. First offense, it is fine up to 25,000 and for second or subsequent offense imprisoned for a term which may extend to 3 years to fine or both. And penalty for transaction in contravention of standard weight measure, it is 10,000 rupees. And for penalty for use of unverified weighter measure, it is not less than 2,000, which may extend to 10,000 rupees. Thank you, sir.
Thank you very much, sir, for your insights into the draft regulations for gas meters in India. You have very clearly explained the provisions relating to the approval of model as per Legal and Metrology Act 2009, Section 22. And you have also clearly explained the maximum permissible error requirements and various performance tests for the meters, and also the penalties related to misuse. So, if there are any more questions from Deputy Director Legal Metrology, attendees can write their questions in the chat box. Currently, whatever the questions has been written have already been answered by sir in the presentation. So I will not repeat those questions. And now we will move to the next lecture. Our next speaker is Sri Kaushik Paitandi, Chief Manager, Head Marketing, Genus Power Infrastructure Limited. He will talk about types of diaphragm gas meters and advantages of diaphragm gas meters. So, Sri Paitandi is an expert in the field of gas metering and has worked with Itron and Secure Meter in his previous assignments. I will request Kaushik sir to share his presentation and start his talk.
it visible?
Yes, sir, it is visible.
Okay. Uh, Thank you, Kundan sir, for the lovely introduction, and thank you BIS for inviting me to this presentation. I will within a short period. This only 20 minutes of time is here, so I'll try my best to finish this within the stipulated time. Otherwise, Kundan sir is here to remind me, so it's okay. Yeah, yeah. So thank you everyone. So my EA is basically I am going to give a brief on functionalities of gas meter, basically domestic diaphragm meters. So, but before that, I would like to introduce Genus because most of the many of you may be knowing Genus, but for a generic platform, creating a platform, I think it's a required thing to use Genus. So, Genus, Genus is a Kailash Group comes under the Kailash Group company. It's a 400 million USD dollar company. We are engaged into design, development, and manufacturing of electricity energy meters since 1996. And recently, last 3 years, we are into last 4 years rather, we are into gas meter manufacturing as well. So we have a state-of-the-art electronic and mechanical manufacturing facilities spread across 5 plants like Jaipur, Haridwar, Guwahati. We are one of the largest smart meter manufacturers in India, and we are a public limited company listed in NSE and BSE. Yeah, under Kailash Group, there are 6 companies basically: Genus Power, Yajur, Genus Paper, Genus Apparels, Kailash Coal and Coke, and Genus Innovation. Basically, Genus Power is the largest among all this, and we are into measuring equipments like meters, obviously, and Genus Innovation is into power backups and batteries and solar renewable energies. This is the power sector leadership from us. We have a manufacturing capacity of more than 10 million meters cumulatively per year, more than 70 million meters deployed across 17 countries, 2.5 million smart meters installed so far as of now, and we are a CMI level 3 company accredited with various national international certification, and we provide end-to-end AMI solutions. AMI means automatic metering infrastructure, which is currently hot topic in the industry, smart metering and all. So we provide that end-to-end solution here. We have an employee base of more than 3,500 active manpowers, and we have a government recognized R&D state-of-the-art R&D facility. This is the diversified product mix of Genus. We are into meters. So we are present in commercial and residential meterings, industrial meterings, prepayment meters, along with the solutions, distribution like distribution transformer meters, gas meters, and gas meters. Also, we are into mechanical gas meters, postpaid AMR gas meters, and prepaid gas meters are also under development. We also provide grease substation and metering ABT compliant meters. ABT means availability based tariff meters. These are the global certifications we have. Just quick, I'm going with due to time constraint, these are CMI level 3 and R&D. All these certificates, needful certificates we have for the global catering of the meters. This is the product customer portfolio. We present in almost 18 countries, mainly African and Middle East countries, including Singapore. And we present in almost all the utilities in India, basically electrical utilities. And currently we are serving gas, most of the gas utilities, that CGDs in India as well, with our domestic meters. This is about our infrastructure. So this is there are the 5 manufacturing facilities. One is in Jaipur, one is in two in Haridwar and Guwahati. Jaipur we have 2 basically, and in Jaipur facility, our manufacturing facility, our gas meters is manufacturing at Jaipur facility. Rest are basically belongs to our electricity meter manufacturing. This is about our research and development. We have R&D recognized by Department of Science and Industrial Research of India. Over 200 technocrats are working over here. We have a national accredited lab here that are BIS and IC certified. Integrated design and development facilities also there. This is our infrastructure facility of fully automated SMT lines. This is basically belongs to the electricity meters. It's a fully automated metering line. We manufactured this in India and various parts of India like Jaipur, Haridwar. We have also our in-house facility for injection molding as well. So any plastic equipments, mostly not all, but mostly we are manufacturing all the plastic equipments of electricity meters and gas meters in-house also. So to ensure the quality of the product for measuring units and all. This is the tool room. So here we are tooling also done by the Genus in-house facility. This is about the gas journey so far for Genus. We have the most important certificates as of now in domestic gas meters are ID, Module B, Module D, BIS certificate. I'll come on later why this is important and all. And we delivered as of now more than 150 K gas meters to various cities in India. We already also delivered smart AMR postpaid meters. Production capacity currently is 30,000. Based on the requirement, we can increase anytime. We have our in-house AMR solutions also, that is meter interface unit MIU. And as I told earlier, payment smart meters with dual communication and all is under development, and we will release this by this year end. One of the important I would like to highlight because there is a common forum this is and everybody should know this. We have a strategic tie-up with Itron oblique right now Dresser. You all I think know about Itron. Itron is one of the market leader in gas metering company based from US. And but unfortunately they are discontinuing from India, and that metering section, especially that commercial industrial metering, that turbine, RPD, regulators, valves, EBCs, all are acquired by a company called Dresser. This is also a meter manufacturer company, but focused basically on North America, American company. Now they acquired their German facility of Itron, and Itron now becomes Dresser. But since Dresser don't have any office in India, so we are now the official channel partner for Dresser. So any meters like commercial industrial meters or regulators, valves, anything regarding commercial industrial measuring, we are dealing with Dresser now, and we'll quote accordingly to tenders and all. So we are the face of Dresser as of now for pan India market. Sorry, it's okay. It's back, I think. So coming to the main part of this presentation, these are the main topics I'm going to cover. This is a gas meter application on domestic diaphragm gas meters, installation of domestic PNG connections, function of diaphragm gas meters, G1.6 diaphragm governing standard and specification, function of diaphragm gas meters with measuring unit movement, function of parts of measuring unit of gas meters. So problem is getting actually next page is getting a problem to me. So is the first, what is the purpose of gas meter? A gas meter is a specialized flow meter which used to measure volume of gases such as natural gas and liquefied petroleum gas. Gas meters are used at residential, commercial, and industrial building. The accurate gas meter or liquid flow measures ensures a safe, efficient, and environment compliant operation in measure applications. You know, there are that's why, you know, gas is a basically a inflammable thing. So that's why all the gas segments are divided into zone 1, zone 2, zone 0. 0 is the highly implement, zone 2 is the lowest one, like this. So meters are normally in general coming under the zone 2 facility. So to ensure that uh, accidents should happen there, so we segregate this into zones. Now there are many types of gas meters: domestic to cater the entire market, commercial, industrial, and custody transfer. This is the basically there are many more type of meters, but basically I am today focusing on main meters in the industry which is available here and which is most in use. First section is positive displacement. Under positive displacement, obviously our topic of today is diaphragm meters are coming, and rotary meters are coming. Rotary meters are basically known as RPD meters also, that is rotation per displacement. So we can have a separate presentation on this because it's a different league of meters. So we are focusing on diaphragm meters for today. Positive displacement meters required fluid to displace component. It's a completely mechanical and measuring volumetric flow. So once the volume, the gas goes into the meter and comes out, so it's absolutely done by mechanical thing, and the measurement is totally depending on the volumetric measurement. So this is about diaphragm, and there are a few more types of meters like differential or velocity meters, like turbine meters, RPD meters. So turbine meters, basically a turbine is inside, and with the flow and the velocity that turbine moves, and it continue to count the measurement accordingly. Ultrasonic, there is obviously purely it's a sensor based meter, and with the differential calculation of the flow from outlet to inlet, and by calculating that millikelvin temperature, they arrive to that flow rates, and accordingly measurement can happen. Mostly this turbine ultrasonic are used in industrial purpose. Rotary are mostly used in the commercial section, and few in industrial as well. Diaphragm mostly used for domestic and as well commercial as well. So because diaphragm, it's a pure mechanical and it's a volume based meter. So what is the happening? Once you are increasing the size, the volume and the diameter, or the area of the diameter, diaphragm meter also increase. So after a certain period of time, that gets so huge, so to manage that kind of size of meter is getting very difficult for any utility. So what they do, they always shift to rotary, which is a compact kind of meter and can measure with a better accuracy for that. So for for every single unit of gas is very important in terms of industrial and commercial, because there is a high volume, and mostly utilities profitability is depending on diaphragm, commercial and industrial purpose. So for that, they always go for normally they go for rotary meters, and for industrial meters higher sizes, mostly turbine meters are in use, because turbine meters, if gas is like impurity is there, some gas are a bit impure, so there is some particles on that. So rotary meters, they have a tendency to get stuck inside. So but turbine meters, if some impurity is also there, then it will move on. So there is a possibility of less, they need very less kind of services for this tenure of their life. This is about the curve. This you can understand the curve and the functionality range of the meters. You can see a small line here. This is the diaphragm. Diaphragm is its capacity, flow rate versus the pressure. So only in this range only diaphragm is operating. This is the range for rotary section, and the larger one is for turbine and high pressure rotary. There are specially designed meters, high pressure rotary. The class meters are defined in classes also, like normally 150 class. There are higher classes like 300 class, 600 class, 1200 class also there. So depends on the pressure and capacity and the flow rate, we select the meter, and accordingly we can design. And one of the main important part, that why we are going with domestic meters, diaphragm meters for the domestic section, or maybe in few commercial sections as well, because of the rate also. Rotary meters are costly meters, so you cannot afford to have rotary meters in domestic section as well because of the ROI issue. So this is one of the important thing, that why we are going with diaphragm meters, diaphragm meter for domestic section. What is diaphragm gas meters? I'm focusing on G1.6 meter, which is the residential meter. So a diaphragm gas meter is a positive displacement flow meter, which is used to measure the volume of gas consumption at low pressure so that the utility can bill for it. It is a specialized flow meter that can measure the volume of high gases like LPG, low pressure pipe natural gas, and etc. It can be used for domestic and commercial purpose. These are the basic certification we required to sell gas meters in India. So this is the main guidelines to participate in the tender or main criteria. So as of now, mandatory certificate is EN 1359. That is the governing standard of that, and the issuance authority is MID. So in MID there are two sections are there, mainly product and the factory. Product MID is known as module B. Factory related certificate is known as module D. So these are the most important certificate which we have to quote any tender or to supply any meters to the utility. Test lab, most important two labs as of now, maybe few more. So I have listed down two only. This is FCRI Palakkad, Kerala, and Jadab Measurement, Udaipur. WNM, obviously WNM certificate is one of the most important certificate. A person must have a valid model approval, license of manufacturing, and sales and certificate dealer's license called for meters to sell these meters in India, and this is are on renewal basis. So we all anyone who want to come in this manufacturing industry of gas meters, they have to have all this certification, and this have some timelines to get it done. So because for testing of module B and all, there is one of the major certification is the durability test. That durability test uh, test up to a certain cycles of lakhs of cycles of meters without stopping the meter, so that it can check the durability of the meters and all. So this kind of time frame everybody have to have maintained before launching their gas meters in India. Is the normal structure just to have a greater idea how where the meter placed and how this is the oven, and before that the meters connected with the GI pipeline, having for safety, obviously safety reason, we have an isolation valve and a regulator. So that regulator, it's basically meters are operating within that 21 millibar of range. So to maintain that pressure capacity, meters regulators in need. After that, that gas went to the go to the meters, and from the meter it will directly go to the appliance. Through appliance valves it go to the oven, the kitchen purpose. This is to give a greater idea how the placement of meters is happening. This is about the cyclic the normal basic parameters of a gas meter, which have to be One is obvious, of course, I told it that EN 1359 is the main standards, European standards, and our BIS 14439 obviously is there, which is under reformation of that. So I think it will be it's already exists, but some reformation is going on. Now coming to this tender technical parameters, one of the important parts, the most here is cyclic volume. As earlier Nayak sir told that there are different type of cyclic volumes. So this is I have mentioned that 1.2 liter, 1 meter, 1 liter, 0.8, 0.6, and I have given a bold on 1.2. I'll come to data why I have mentioned that 1.2 liter. So cyclic volume is the volume of gas passed by one rotation of the gas meter measuring unit, and is 4 times of the volume of the diaphragm. Because the gas once I'll show you I have a small video on that, so you will get the clear concept on this part. Maximum flow rate Qmax is 2.5 meter cube per hour. Minimum is 0.016. Maximum working pressure is 0.5 bar. And working temperature is it's all in standard basically. So working temperature is -25 to +55 degrees centigrade, and the accuracy the curve is -%. So this is see this I arranged this video. So can see how the gas is going inside and coming out. You can see this is it's 1.2 liter rotation, means one cycle how it's going to. I am going to play this once more. You can see once the gas is going from one chamber, so it's expanding the diaphragm, and then it's going to the next level and it's compressed that. Once it's get compressed, it will go to the next outlet chamber from inlet to outlet. Again, it expand and compress. That's why it's called four round of diaphragm compression and expansion, so that it will create one cyclic volume. And different manufacturers are following different size of cyclic volume, 0.2, 0.6 point later, depending on the structure of the measuring unit. Will show that the less the cyclic volume is, the measurement counter size will also getting less, because of the diaphragm size will getting less. So you can see once more, it's going from inside, then that side, again it's coming out, rotating, and the gears and crankshafts are rotating accordingly, so that it will create that one unit accordingly. Yeah. So here we have done a small kind of to understand in a better way the cyclic volume. Say we have given our to all type of these are the cyclic volume in liters: 1.2 liter, 1 liter, 0.8, 0.6. I mentioned only four kinds of. And if we pass 10 liters of gas or air, whatever, so to this, to measure this 10 liters, a 1.2 liter cyclic volume will get 8.33 round of rotation, whereas for 1 liter is 10.8, it's 12.5, and 0.6 is 16.67. So you can derive from here only that the more the liter the cyclic volume is, the less the rotation is. That means the wear and tear accordingly will be less for any meter. So you can anyway get same similar kind of measuring unit and measuring calculation on this part. Per unit will be same for every volume, cyclic volume, but the working capacity will increase as and when you are decreasing the cyclic volume. So that's why in our co-host already told that why 1.2 is a better choice. This is the diaphragm typical look. I think many of you have not seen how diaphragm looks like. So this is the rubber kind of thin rubber, synthetic kind of thing, and it's placed on a aluminum plate so that it will get stuck on this part, and it will compress the gas and expand the gas accordingly. And the size of the diaphragm depends on the cyclic volume. So the lower the cyclic volume, lower the size of this diaphragm. So you can now, this is another video. You can see the functionality of gas meter in a better way over here. See, the gas is going inside there. This is the inlet. Once this gas is going inside, so this is the casing, outside casing, and the measuring unit is inside, which is measuring the gas, and it's coming out. Now, index accordingly, the crankshaft is rotating. According the pinion gears are rotating, and these gears are connected with the counter, measuring counter, which is accordingly getting rotated. So by this, you can measure the cyclic, the SCM or gas volume per unit like this. So this is the inside mechanism we are following for this. Like this, the gas is going in and out, and diaphragm is getting two type of compression and expansion. Accordingly, the gases you measure. So I hope this will give a basic idea on the functionality of gas meters. So once this gas is going in and out, that means one cyclic volume completed. Now coming to that year part, how this rotation is coming and how this once this part inlet and outlet, once it will open once the inlet is out, that time the outlet is closed, and once this inlet part is closed, then outlet is open. So the gas will transfer from one chamber to another one by one, not simultaneously. For this we have this video. This is the mechanical part. As I told you, that is a purely mechanical thing. So all these gears are rotating accordingly. This point, this point, this is the main connection from the inlet to the outlet, and this gear is moving accordingly. These two gears are moving, and the counter is rotating accordingly.
Kaushik sir, please conclude.
Yeah. I don't know. It's getting some. Going to this next slide is getting a problem for me. Second. Gone, right?
Yes.
This is the coupling. In my last slide, I shown that how this communication happening. So this is the coupling. Couplings are of two type. One is magnetic coupling, one is mechanical coupling. In mechanical coupling, what we are doing is VA is completely mechanical thing, so it needs very preciseness. But advantage of this is a purely tamper proof, because no magnetic tamper proof, because it's there is no use of any magnet or something. But in this type of inductive coupling, magnet is in use. So by the induction, this rotate moves. So it's have a ye ki there we don't need any holes or something kind of that in the body of the casing. But here we have to very precise also, that it will not, it will follow that IP rule as well, and the counter will move as well. So there a small test we have done here, that if you place, just going fast, if you place a 5 Tesla magnet, or maybe 0.2 Tesla as well magnet over the main of the counter, and this counter, the rotating factor, if it's magnetic, then it will the meter will get slow. If this is a mechanical kind of coupling, then it will not, because there is no use of magnet or something like that. So it's always better to go for a mechanical coupling. These are the main tests where we do before supply the meters. One is external leak tightness, one is error of indication test, and pressure absorption test. So they have all these are defined in 1359 standard, and accordingly we follow this, so that the meter will be, each and every meter should be supplied as per the standard. These are the main certificates we need for the factory. That's ISO 9000, 14001, 27000, and 45000, what we already have. And these are the main certificates we have for the gas meter to supply. One is, I told you earlier, one is module B MID, module D MID, module B MID, model approval from WNM, and the dealer's license from WNM. These are the major 4 certificates. All from my side. I hope I have given a brief knowledge. I'm able to scatter a brief knowledge on the functionality of diaphragm meters. Thank you from my side, and thank you everyone for listening me. If you have any questions or answers, please contact Kundan sir for this. I have to take those answers. Thank you.
Thank you, Kaushik sir. You have very beautifully explained the working of the diaphragm gas meters and
Thank you.
issues related to the cyclic volume and magnetic susceptibility. You have also explained the types, selection, and uses of gas meters and their advantages in terms of ROI. So I thank you for your insight into this. some members are want to discuss regarding cyclic volume. We will have a discussion session where I would invite some of the attendees also to discuss with the panel experts in the end. I will take one question. What is the significance of transient flow rate QT in gas meters?
Okay, QT actually, the range is Q min to Q max. So, to go from Q min to Q max, to measure it more properly, we have in between a transit, that is T is for transit here. So, if you consider overall the error factor plus minus 3, you can have 1.5 plus minus from Q min to QT and QT to Q max 1.5. So overall, it's I think the range, to define the range in more clear way, this Q min to Q max QT is for this transit. Yeah. I think Nayak sir will also be able to explain this in a bit more.
Right, sir. So there are more questions from Mr. Anand Langalia also. What is
Yeah.
the calibration life cycle for diaphragm meters? Nayak, you can also answer if you would like to. So Kaushik sir, please, if you want to answer this.
This one, yeah, obviously. This one, actually, normally, as a, there is no such definition in standard for the life and all. But what we suggest from the manufacturing side, a normal life cycle, if you ask the manufacturer, it will be more like 6-7 years. Even Nayak sir also shown in his slide also about the life. So 7 years for the domestic diaphragm meters, but utility normally asking for 10 years, maybe 15, 20 years. And this will be done also, but that's not doesn't mean that within 7 years it will get stuck or something. But ideally, if you ask a manufacturer or maybe a standard regulators or maybe WNM, they will advise you for maximum 7 years. But provided, one of the important, again, I'm coming to the cyclic volume. Because of that, the lower the cyclic volume, the more it will do the exercise of the durability will decrease. So it's depend on the meters EA. Moreover, it also depends on the gas purity also. The more the gas is pure, the life will get exchanged. And periodically, after 7 years also, periodically, but gas meters are so in fact, it's domestic diaphragm meters. ROI is one of the most important. Otherwise, you may get it calibrated and resolved, but the calibration charges itself is so high, you can buy another new meter. So for domestic, for commercial diaphragm meters or maybe for RPD meters, periodic calibration is always recommended within 2-3 years maybe. But for diaphragm meters, it's always better to get it changed within 7 to 10 years.
Thank you,
Thank
sir. And some of the questions will be answered by our next speaker, who is an expert in the testing of meters. So our next speaker is Sri Bal Mukund Vyas, Chief Scientific Officer, Yadav Measurements Private Limited. He will be talking about differences in current Indian standard IS 14439 Part 2 and the new draft Indian standard on diaphragm gas meters. So Sri Vyas has vast experience in electronic manufacturing, quality systems, laboratory management and testing. He is a qualified lead assessor for ISO 9001 and IS IEC 17025 and is an empaneled assessor for NABL. So I will request Sri Bal Mukund Vyas sir to start his talk.
Good afternoon. Are you able to listen me?
Yes, sir, you are audible.
Right. Good afternoon to everybody. And I will like to first thank BIS for inviting me to talk on this very important subject. And which I will be specifically talking about because the PGD 26 committee is at present working on revising the IS 14439 standards. These standards were made long back, so the committee is working and a draft standard has been made. So I will talk about some salient features of these draft standards and why this draft standard is required. Now, before doing that, of course, I will talk about what is expectations of different stakeholders for the gas meters and what are expectations from the standards. What is the current standards, IS 14439, in brief, and what is changing scenario and what is the context and why do we need to revise this standard IS 14439. And as I told you, we have a draft standard which has been made by PGD 26. This is under circulation, and so I will touch upon some of the important salient features with respect to the old standard, that what are the changes we are doing in IS 14439. Before doing that, just a brief introduction of my organization, Yadav Measurements. We are an NABL and UCAS accredited test and calibration laboratory. NABL, I believe most of you know, it's an apex body for accrediting test and calibration laboratory in our country. And UCAS is United Kingdom Accreditation Service. We are the only accredited laboratory by UCAS for electricity meters, gas meters, and various test facilities. And of course, we are a BIS recognized laboratory for electricity meters and gas meters, also as per Indian standards. As far as I know, to the best of my knowledge, we are the only recognized laboratory by Bureau of Indian Standards for IS 14439. And of course, we are recognized by various electricity regulators. We are based in Udaipur. Of course, we have a lot of test facilities for electricity meters, but I will not talk about those things. We have EMI/EMC test facilities. We have environmental test facilities. We have climatic test facilities, mechanical, and all those things. But here, for the benefit of all attendees, what I would like to talk about is that we have extensive test facilities for calibration and testing of gas meters. We can test for accuracy the meters from G1.6 to G1600. I will show you some of the test facilities. We can test all type of meters as per EN 1359 2017, and all these test facilities are accredited by NABL and United Kingdom Accreditation Service, and the test certificates issued by our laboratory is acceptable not only in India but worldwide, because we have United Kingdom Accreditation Service. Like we are accredited for EN 1359, OIML, EN 14236, even the latest standard EN 17526, which is for thermal mass meter for European body. So our test certificates can be used for getting various certifications by manufacturers or by CGDs or any other stakeholders. These are some of our facilities. The test bench, what you see on the left hand side is basically a test bench up to G6, G1.6 to G6. And what you see on the right hand side is basically the primary standard for volume measurement, which is Bell prover. And we have one of the best CMCs, that is uncertainty of 0.16 to 0.2% for the Bell prover. We also have another test bench which can test the meters up to G1600. Means you can test the accuracy of the meters up to 2500 meter cube per hour with an accuracy of plus minus 0.2 to 0.3%. One of the best facility we have in India. And also I will like to add that we are the exclusive partner of Itron. Now it is known as Dresser, for repair and calibration of the gas meters in India. So with this background, I will like to go to the original subject of the gas meter standards. So I will start with what different stakeholders actually expect because the standard should meet the expectation of the all stakeholders, be it manufacturers, be it CGDs, be it users, be it regulators, or be it consumer forums. So what people expect, what the stakeholders expect from the gas meters. So first thing is it should be reliable, robust under various stresses. The gas meter has to work continuously, unattended, 24 hours, because the gas can be used by the user anytime, 24 hours. So it should be always working 24 hours unattended, and mostly people will expect that it will work without any problem for at least 10 years. Accuracy. Today, we are using mostly class 1.5, but people will expect more accuracy. And also what we need to note is that the gas meter accuracies are not only the direct accuracies, but they are affected by temperature and the pressures. So that also has to be considered when we talk about accuracy of the meter. And another important aspect for the gas meter is it should have sustained accuracy. Means it's not that the meter, when it is tested at the time of type test or routine test or acceptance test, it is okay. But it should sustain its accuracy for 10 years. And of course, it should be testable. We are into information age, and nowadays information and communication technology is very much required, and it is a focus of Ministry of Information Technology and Government of India. So the meter should facilitate easy reading and billing, should facilitate digitalization, and it should be smart. Like many of you might be knowing that in electricity meter, there is a separate standard for smart electricity meter, and in our country, there are already probably more than 5 million meters, or maybe 50 million smart meters already installed in our country. So the standard and the expectation of the stakeholder is that whatever standard which we make now should be smart, should support the smart digitalization of the industry. And the safety, of course, is the basic requirement. The gas meter has to be leak proof, it has to be fire safe, and it has to be corrosion resistance, because meters are installed in different environments. So with this background of expectations from different stakeholders, what people will expect from the standard, we are making new standards. So standard should support mass manufacturing. The standard should not prohibit manufacturing. It should support mass manufacturing. It should support mass installation. So installation should be easy. Installation should be standardized. It should be meet requirements of reliability, safety, sustained accuracy, easy reading and billing, easy installation. It should be suitable for Indian environment. Very, very important, because the India is a country where we have a wide range of climatic conditions. If we look at from Jammu Kashmir to Tamil Nadu, then we have east to west and north to south, we have different climatic environment. So, and our standard is applicable all over. And as we were talking about digitalization, and standard should be unambiguous. Many times we find that there are ambiguous requirements given in the standard. So we should try that standard is unambiguous to ensure that variability is as minimum as possible, and the interpretation should be clear. Testing and certification methods should be well defined. Acceptance criteria should be well defined. type test and acceptance test and routine test should be part of the standard. Sorry, I don't know. Yeah. Okay. Now, just a few minutes on old standard IS 14439, which was made in 1997 or 1998. Of course, this is old standard. This was based on OIML R6 1989. Maybe at that point of time, this was the standard for the gas meter. It only covers class 1.5. The digitalization and the communication technologies, of course, they were not, at that point of time, they were not the need, so they are not covered. So no additional functionalities requirements are given. Starting flow rate is not defined in the standard at that point of time. And the temperature range defined in the old standard or the existing, in fact, this is not old standard, it is at present the valid standard. But the temperature range defined is -10 to 40 degrees centigrade. Now, what is changing scenario? As I told you, information and communication technology is required nowadays in all our aspects of life. The testing methods have changed. 1997 or 98, a lot of testing methods have changed, have improved in terms of the repeatability, improved in terms of measurement techniques, improved in terms of accuracies. So new testing methods have come up. So we need to incorporate all these new testing methods in our upcoming standard. It should support mass scale manufacturing and installations. It should meet the regulatory requirements like PNGRB or any other regulations. What industry expects? Industry expects that it would be integrated easily with information technology infrastructure, better accuracy and robustness, like CGD wants that as accurate as possible, and the meter should be working long duration, at least 10 years, quick reading and billing, so that the finances of the CGDs are quickly recovered. At present, we are doing postpaid billing. So postpaid billing means the CGD is getting the money after supplying the gas, maybe after 2 months. So today, if I am using a gas, I will be paying after one month or 2 months or 3 months. And of course, the meter should be economic. What end user expect? End user expect that the meter should be accurate. The accounting of the gas use, which as a user I am doing in my home or in my industry, it should be visible to me how much gas I have used and maybe at different time of use, and it should be safe. Coming to the draft standard, which the PGD 26 has made, I will like to make a disclaimer here once again that this is at present a draft standard, and whatever I am talking about is subject to change because a few more discussion will happen on this standard. So some of the new things might come into the standard and some of the things might change from whatever I am presenting it here. But I am sure that BIS has a process for circulating the standard before publishing it. So it will go to wide circulation and all stakeholders and all members who are today attending this presentation can view the standard and give their comments. So this standard which PGD 26 is making is based on the latest European norms EN 1359. Means guidance has been taken from EN 1359 2017, also from OIML, which is Legal Metrology International Organization, OIML R137 document, Also, for additional functionalities requirement, guidance has been taken from European norm EN 16314. And of course, I am also member of the committee who is making these standards, and lot of highly experienced people from different sectors are part of this committee, and they are giving their best to make this standard as good as possible. So I will give a brief on what are the new requirements as compared to the existing IS 14439. Is that we are adding starting flow rate, and as I have interacted with a few CGDs, they have complained that existing meters, when the people are using those meters at very low flow rate, they are actually not recording the volume. Means the consumer is using the gas, but meter is not recording the volume. So starting flow rate should be required. Once you define the starting flow rate, then these meters, the design will be required to measure some minimum flow rate. So that is what is one of the requirements we are adding. We are adding influences of other devices, like as I told that the meter will have a lot of additional functionalities, how it can influence the performance of the meter. Resistance to high ambient temperature, because sometimes there can be a fire in the building, in home. Even in that case, the meter should not leak, it should not aid to the fire. So that is the requirement. Resistance to heat, a high ambient temperature, it is proposed to aid. Standard have very good mechanical performance test. Better mechanical performance requirements are added. Better metrological test requirements are added. In fact, we are adding class 1 also instead of class 1.5. So there will be an option of class 1 and class 1.5 both. The CGD or the users can select as per their need. Electromagnetic compatibility test, we are referring to the latest standards. Similarly, the climatic standards, we are referring to the latest standards, and we are extending the ambient temperature requirements for the gas meter from -10 to 40 to -10 to 55 degrees centigrade, which we believe that will meet the requirements for our whole country. That is why we are increasing this range. In addition to that, we are adding that the requirement that the meter should work efficiently and correctly with a gas temperature of -5 to 40 degrees centigrade. So we are adding this also, that the gas temperature also should not influence the performance of the meter. And of course, corrosion is very important for the gas meter, because corrosion can make the meter unsafe. So there are lots of corrosion resistance requirements we are adding, and also we are adding overload flow withstand capability. But sometimes if the meter is faced with a flow rate more than Qmax, then also the meter should not get damaged, and it should work correctly when the flow rate is normal. So coming to the corrosion resistance requirement, we are adding the requirement scratch resistance of the protective coating, the adhesion of the protective coating, how strong is the adhesion of the protective coating, impact resistance of the protective coating, chemical resistance of the protective coating, resistance to salt spray, and resistance to humidity, and resistance to storage temperature. So all these tests, all these requirements, it is proposed to add in the standard, so that the meter has very good internal and external resistance to corrosion. As far as mechanical requirement is concerned, we are adding robustness of the meter case, which is very important. Meter case should be very safe. there should not be any leak. So external leak tightness test, resistance to internal pressure, and sealing requirements. Also, the connections are being, there are requirements related to the connections, because sometimes there can be a leak from the connections. So connections, test for the connections are also being added in terms of thread strength, in terms of torque, in terms of bending moment, and of course resistance to vibration, resistance to impact, and resistance to mishandling, which is basically a drop test. As I told earlier, we are adding a requirement which is named as additional functionality requirement, and this additional functionality requirements will actually support the integration with the digitalization and make it smart. So there are three types of additional functionalities defined, which is called AFD1, AFD2, and AFD3. As you can see, AFD1 is basically the additional functionalities which are integrated part of the gas meters. AFD2 is additional functionalities which are attached to the gas meters, and they can be removed, but they are part, or they are integrated along with the gas meter, but they can be separately identified. And AFD3 is type of additional functionalities where there are two different blocks, two different identity of the additional functionalities. And these additional functionalities requirements will support prepayment functions, which will be very useful for the consumer also and for the CGD also. It will support software security and the firmware upgrades. If this is a smart gas meters, it will support tariff management and battery management. And also it requires specific, because prepayment function will require a shut off valve. So this valve can be shut off and shut on depending on the payment is pending from the consumer or not. So the valve performance becomes very, very important. So this is about additional functionalities. And of course, a lot of new test methods, improved test methods, because as I told, sustained performance is required. So we are adding tests related to aging, related to environment. So meter will be required to work continuously at high temperatures. Meters durability test, that if continuously there is a flow and the flow rate is changing, whether the performance of the meter is getting affected. Salt spray test. Metrologically, we are adding weighted mean of error for the full range to ensure that the meter's accuracy is controlled not only at a particular flow rate, but for the full range. We are trying to ensure that the tolerances and acceptance criteria are well defined. And of course, there are many more improvements compared to the IS 14439 1997. So this is about this, and what we expect actually from all of you, those who are members of PGD 26 and those who are not member of PGD 26. We want that you all go through this draft standard, which I'm sure will be circulated by the Bureau of Indian Standard, and provide all the comments. On behalf of BIS, I will like to mention that all your comments will be duly deliberated by the committee and considered for the improvement of the standard. What we want is the standard which we are making is one of the best in the world, and our standard published by Bureau of Indian Standard is not only used in our country but is used by other countries, which will enable not only make in India but enable export by the Indian manufacturers. So thank you very much, and I'm sure we will be able to publish a very good standard. Thank you.
Thank you very much, sir. You have very beautifully summed up the changes that we are incorporating in the new version of the current standard. you have explained the expectations. Excuse me. You have explained the expectations of the stakeholders from BIS as well as the expectations of BIS from the stakeholders. So, what I wanted to tell all the stakeholders you have already included in your slide. So, thank you very much for that. And surely we will be able to reduce the shortcomings of the previous standard and publish a much better standard. So, with that, I thank you for your presentation, and let's see if we can take some questions at this point of time. So one question is from Mr. Vipul. Can AFD be retrofitted to existing OD meter?
Think yes. I think the manufacturers will be better about as far as I told you, there are three types of AFD: AFD1, AFD2, and AFD3. So I'm sure AFD3 can be retrofitted, but if it is AFD1, definitely cannot be retrofitted because it was integrated part of the gas meter. And AFD2, depending on the type of design of the gas meter and the AFD, maybe it can be retrofitted.
Thank you, sir. And I think we will take the other questions in the question answer session during the discussion. Now,
Thank you.
Thank you, sir. And now I will invite the next speaker, who is Shri Patranjan Bhattacharya, Strategic Business Development, Secure Meters Limited. He will share his insights on expectations from metering, regulatory alignment, and guidance. So, Mr. Bhattacharya has over 20 years of experience in energy and utility sector and is an expert in smart metering and demand response technologies. So I will request Patranjan sir to share his presentation and start his talk.
Yeah, very good afternoon, good evening to everyone. Am I audible?
Yes, sir, you are audible.
Okay, thank you. Thank you, BIS, for giving us this opportunity to air our views and probably share different perspectives and what is going on in the field of metering exactly, rather domestic metering. Just before my presentation, Mr. B.M. Vyas actually partially stole my thunder. I wanted to capture and talk about a few things which he has already touched upon. But I am not directly getting into the nitty-gritty of the standards. I'll touch upon a slightly different aspect, which should be or directly or maybe indirectly addressed in the regulations, either regulations or the standards. So basically, when we look at a CGD and a consumer, what exactly is a CGD looking for in terms of its day-to-day operations, and what exactly is the consumer looking for? The CGD on the left-hand side, there are all these things are directly or indirectly related to cost. So you might see a similar thing repeating, a few points repeating in subsequent slides. My presentation is not very long. But yes, you might just see certain things repeating. Operational efficiency, low cost to serve, robust and reliable solution. That is what CGD is basically looking at purely from a business perspective. Consumer, he needs to be kept informed. He needs a hassle-free usage and he wants a convenience whenever he is using gas. So basically, if I go into the CGD perspective, there are various things that add to the operational performance. What are the expectations? Expectations are costs, reading cost should be minimum. There should not be error-free meter reading should be there. Bill reduction cost, bill distribution cost should be very low. 100% collection efficiency, no bad debt, minimum billing cycle. Now, basically, what do these lead to, and what are the supports in the system that are required, or rather, a regulatory support that are required? The things that I've put in green are partially addressed by the regulations as on date. Meter should be able to calculate the cost of gas use. Data should be sent to backend. Now, a couple of years back, when PNGRB came out with a regulation, with an update on the gas metering regulation, so these points were added. Advanced collection and old dues recovery, of course, they added a prepayment mode. Support of auto disconnection, they added a valve into the meter, which is basically supported in the new regulation now. So, at the same time, the operational efficiency does improve if the consumer is also continuously updated on his consumption. It should not happen that suddenly he gets a shock on a later date. Now, next again, low cost to serve. Here the expectations of the CGD is lifetime cost against L1 cost. Typically, buying practices are on L1, but the thing is, how long that meter is going to be there in circuit, what is its reliability, etc., needs to be taken into focus, needs to be taken into consideration, and its lifetime needs to be calculated. What is going to be my manpower cost? If I put an asset on the wall, what is going to be my manpower cost? What are going to be my IT infra that I need to put? And am I adding non-value works for which I am putting a lot of people for doing those non-value added jobs? Now, again, one of the good things that the PNGRB regulation has done is like what they have added is the prepaid function to the meter. But the thing is, what probably more needs to be done is elimination of certain IT modules. Now, prepaid is something which is which you pay in advance. You really don't require a bill for that. You get whatever maybe 100 rupees you have paid, you get a receipt for 100 rupees. You don't need to wait for the bill for that. So that is something which can probably be taken care into the regulation. That is the reason I put it in red. Now, the meter should have that self-sufficiency, as Vyasa was also saying, going towards digitization and intelligence into the meter. So the meter should have that intelligence to calculate based on it should be able to support various tariffs and other things. And of course, long warranty period, because I am relating it with the lifetime cost of the product against L1 cost. And the actual manpower, which are probably being utilized for certain other purposes like metering, like billing, collection, bill distribution, etc., they can actually be deployed for more useful work like network growth and maintenance. So that's where CGDs really can probably focus on as on date. And of course, you need to have pretty low recurring communication costs. Again, I'm not getting too much into this. One of the things Vyasa touched upon, which is being which is being added in the updated standard, is the AFD type 1, 2, and 3. Ideally, it would this ideally what happens is you need to look at the robustness or reliability of the whole package, not just the product. When you're talking of package, maybe if you are going for communicating device, then the AFD plus the meter becomes your package, and then whatever is the software behind it, that becomes also a part of the package. So the thing is, robust, ideally, if it is an integrated product, meter, module, communication, etc., whatever are the parts of the thing, that creates more robustness because that is inside a single box. There is no external communication, no external retrofit devices. So that gives a more robust solution that way. That's a suggestion, because although the standard supports everything, but this is something which can be thought of. Of course, the design life should be long, and at the same time, the meter should be ready for upcoming needs. Part one of the thing is the product should perform as per its dharma. Product जो धर्म है वो है it should be able to measure continuously and properly, non-stop, without any intervention, and correctly over its lifetime. That is the dharma of the product. It should be able to do it over its design life. Design life कुछ भी हो सकता है, 5 साल, 10 साल, 15 साल, जो भी हो सकता है. And there should be इसकी एक warranty period होगी. So that warranty period is something which is given by the manufacturers. But at the same time, you also need to be sure, is my product going to be ready for future or upcoming needs? For example, today we hear, rather here, this is something which is probably going to come up in the next few years, which is hydrogen blending. Number one. Next, CBG addition into the PNG network. So one needs to think, is my present product or measurement that I'm doing, is that future ready? Is it going to be able to support all those new additions that are going to come? Government has already said, MOPNG has already said, PNGRB has also come up with regulations for them. But the thing is, at the same time, the CGDs need to think, the measurement product that I am putting on the wall as on date, is it going to be ready for the future, ready for the next 10 years? That's a question that needs to be probably asked. So that's one part of the thing. And then that was these 3 slides were basically on what is the expectation of the CGD. Now there are certain expectations from the product which is installed on his wall from the consumer side as well. The consumer should basically, if the consumer has to, if he has a connect with something which is measuring how much money he has to pay, he will not get a jolt later on. Consumer doesn't understand SCM, but he understands what is money, what is rupees. And if he is able to get some kind of a continuous feedback, either from not getting into communication or that part of the thing, if there is a mechanism for the consumer, either directly from the meter, or maybe some kind of a mobile device, or maybe from the backend, if he is getting some kind of an update, so that is something which is going to help the consumer as well. Monetary information, some kind of an alarm usage, maybe various kinds of payment options, various kinds of flexible recharges. So all these things are something which need to be supported. Ideally, these should be supported and looked forward by the CGDs for times to come tomorrow. There are certain things I would go into, and like as of now, primarily, of course, this is because the topic over here is domestic metering. So the technologies that are available as of now, if we just look at electricity meters are open to measurement technologies like CT, whether shunt or Hall effect sensors or air core transformers, etc., etc. So here also metering technologies in gas metering are also available, different types: diaphragm, ultrasonic, thermal mass flow, etc. The end objective should be low cost, long life, and future ready. All the products have all the different technologies have their advantages, disadvantages. I'm not getting into them. Diaphragm is a time-tested, proven design. Ultrasonic is something which can be used over a long range and over high temperature. Thermal mass does not require any temperature or pressure compensation, or blending of hydrogen is possible. It supports that. So all these things may have their unique advantages. At the same time, the whole thing needs to be thought of. The advantages and disadvantages of different products, maybe different technologies, may be different. So all this needs to be factored in by the CGDs when taking a decision. Again, this is directly not related with the standards part, communication technology, But somewhere or the other, there are various technologies. One needs to take a decision on what is my lowest recurring cost, and it is suited to the need. It should not happen that you specify I need LoRaWAN, or I need NB-IoT, or I need near field communication. See, the thing is, you cannot randomly specify what communication should be there in the meter. It purely depends on the topography of the place. So basically find out the topology and then decide about it. Metering type, of course, there are postpaid is a normal credit meter is defined as part of the regulation. Here, this is where we get into the regulation, and this can be, there are certain things which can be thought of. Postpaid or credit meters were there. PNGRB has introduced smart prepaid, smart prepaid with communication. So that has been introduced. Can an in-between meter, maybe a prepaid without a communication, be introduced? That is a thing. That is something which can be thought of, or maybe even a credit meter with a valve. This will help facilitate certain processes like manual disconnection, manual temporary disconnection. These are certain things which can probably be thought of. And remote disconnection, maybe credit meter with a valve with remote disconnection, with a communication and remote disconnection, will basically serve the purpose of will cut down on certain costs where the CGD has actually to send the manpower. These are certain things which can be thought of, and maybe some of them can get into the regulation part, regulatory requirement. Overall, basically, when we take a decision on that, whichever CGD takes a decision on that, their requirement should be lowest cost to serve, and whatever is something which is suited to their requirement for serving in the most cost effective manner, that is something they need to look at. I'm coming onto my last slide now. Now, one of the things that I would like to raise in this forum is maybe there are multiple approvals are required in our system, at least in India. For example, if you just look at the European Union, what they require is just MID. United Kingdom, UK requires MIR, a single certification, basically single testing. Bangladesh, they require EN 1359 or OAML R137. India, there are two things. One, you have to test as per standard, and then you have to go to weights and measures. Other requirements, other testings are similar in different countries, but here I would suggest that there could be some kind of a mechanism for single window clearance for approval of the product. What exactly it will do is it will help shorten the overall approval process and the cycle of approvals. Harmonization of standards and legal metrology requirements, maybe 1359 and the legal metrology requirement. This is something that would go a long way for serving this, and I think that could be the way forward. Maybe of course the functions, consumer ministry and all, they can probably take a decision on that. This is just a suggestion from a manufacturer's perspective. Okay, thank you. I'm through with my presentation. That was short.
Thank you very much, sir, for letting us know the expectations of the CGDs, consumers, and also you highlighted the issue of regulations in India and how they can be made better. So we will take the questions in the question and answer session, and I will quickly move on to the next speaker because of the paucity of time. So the next session will be taken by Sri C.V. Suresh, Chief Research Engineer and Head of Air and Gas Flow Laboratories at the FCRI, that is the Fluid Control Research Institute. Sir has over 25 years of experience in calibrating and testing pipe of flow products, gas flow meters, site calibration, metering speed validation, designing and developing special application flow meters or metering methods, and gaining model approvals of flow meters or flow products. Today, he will be delivering a talk on testing infrastructure in India for domestic gas meters. So I kindly request sir to share his slide. Okay, he has already shared. So sir, you can please start your presentation.
Yeah, thank you. So my slides are able to see?
Yes, sir, it is visible.
Yeah, thank you. Thank you, sir. So I'm CB Suresh, and I'm very thankful to BAS for giving me an opportunity to be part of this wonderful session with the best available experts in the panel and the audience. So I'm sure most of you must be aware of FCRI, Fluid Control Research Institute, Palakkad in Kerala, situated the southernmost states, one of the states in India. They are pioneers in fluid flow measurement and calibration activity. This was set up with the UNDP 8 in 1989, and by that time there were no experts, reliable experts in our own country to have or to make a setup regarding the fluid flow. So this was set up by the UNDP assistance and Government of India assistance. And we started functioning in calibration and testing of various types of flow meters. So we have basically many different laboratories, of course, in different media like air, water, and then in oil, water and oil in liquid medium, and at present air in gas medium. We are looking or developing something in natural gas also, but it may take time because of some unexpected hindrances in the development. It is slightly delayed. So coming part of the airflow facility, we are one of the best facilities available in our country, which are experienced by many of our colleagues from different manufacturing units, users, and flow meter developers, end users, etc. Most of the manufacturers, they already used our facility or being used our facilities. One of the facilities which are at par with many international standards also, those who are participated in FCRI and many other different laboratory. The accuracy what we claim and the within our range, it is at par with many other foreign laboratories. And at present, we do extend our service to many countries outside India. Some of the tests it is including Middle East, then some of the Israel, Scandinavian countries, so USA, so many manufacturers from across the world, they use our facilities. Coming to the today's subject on this one, something related to the gas flow measurement, we have testing of diaphragm gas meters as per BS standard, OMS standard, and IS standards, testing of turbine RPD meters as per different national or international standards. We do model approval test of diaphragm gas meters and associated regulators also. We have the facility at close to atmospheric pressure. We can start a flow rate of 1 ml per minute to about or slightly more than 10,000 meter cube per hour. And at an elevated pressure up to 20 bar, we can cover the range up to 400 meter cube per hour. So many of the CGDs companies in their distribution or measurement flow meters are being used our facility, high pressure and low pressure airflow facilities. And along with the flow measurement lab, we have all other associated parameters also can be calibrated instruments like pressure, temperature, current, voltage. So flow, vibration, noise, flow and related parameter, we are one of the largest laboratory in the world itself. And our accuracy is also very close to international levels. And that is definitely by the help of our users and our government and the visionary of our earlier engineers and other government officials. We do validation, calibration of flow meters, installations, and if any specific problem is identified by any of the manufacturer, any of the user at the site or manufacturer after installation, we extended our service to resolve those issues from the field study, and then developing some metering techniques which are suitable to that particular application. So many such installations have been done, installed, and validated. So these are some of our area of work. Coming to the gas, domestic gas, we did the first model approval in almost 20 years back. Unfortunately, the first few companies who have taken model approval from our end is not there in the field now. So diaphragm gas meters, it starts from G.6 to G650. But as many of our experts told, in present Indian condition, G1.6, G2.5 is the most populated ranges. And of course, earlier G4, G up to G25, G40 was also being used in industry. But considering the accuracy of the meter that can serve, it's slightly inferior to some of the new technologies, and slowly some of the industries, they have shifted from diaphragm type meters to rotary type meters, considering the better accuracy and higher pressure, operating pressure. And why a model or type approval is necessary? That is, if any manufacturer, if they produce any new meter, how to give a confidence that that particular model is capable of metering to the national or international levels, accuracies, and the government body can accept that manufacturer. So in Indian government directly under, they do not have any laboratory. So now they depend on other laboratories and they do the testing, and then after the test, they share the certificate with the approval agency, government agencies, and based on the certificate, they accept that particular model. So new and upgradation of the models are keep on happening, and once any changes are involved, a new technique is being adopted or any attachment is there, it should be validated through proper test. And our present Indian standard does not cater to many of these stringent tests which cover in some of the foreign lab standards. Earlier we have, presently also we have IS standard 14439, which is under revision now, and OIML R137 and BSEN 1359. Out of this one, OIML R137 is general recommendation for all types of flow meters which depend on different principles of operation. And IS standard is typically focused on diaphragm type meters, and EN 13959 also focus on diaphragm type gas meters. So if you compare the Indian standard, old Indian standard, and the BS standard recommends much or many more tests which are more realistic to the operating conditions than our Indian standard. And now I congratulate the BIS to adopt or make a revision to the standards, that our standard is also in par with the international developed countries standard what they follow. So we are in the process of upgrading many of the standards. So we are happy that we could also take part in this aspect in 1359. So basically it covers error of indication, so many tests which are described by many other panelists earlier. First model approval test we did, first 2 or 3 model approval test, it was not based on Indian standard, it is based on EN 1359 standard. So at that time itself, the manufacturers were having the feeling that following the developed available acceptable standard, which may be superior to the national standard, will help them to cater to the future also. At that time, it may be it was, I think, at least 18-20 years back. So after that, they have withdrawn from the market due to many reasons, and now many manufacturers are available in India. They import directly the whole unit or import the components and then assemble here. However, whatever is the procedure, it should be and the meter produced or the product should be validated by any Indian agency. Now, apart from FCRA, there are a few more laboratories who are capable of doing these tests. These are all some of the tests what we do, and these are 137. These are all a few tests, and the EN 1359 being exclusively standard for diaphragm gas meter, it explains it to cover many more tests. These are all the tests earlier FCRA was serving. Of course, we don't claim that all the tests recommended by the standard is able to cover by FCRA. So we focus or cover most of the tests that related to flow and related area, and remaining few tests for casing, metallurgy, and for the rubber and the casing components. Of course, they have to depend on other laboratories to get it certified and then submit all the certificate together to the legal metrology for acceptance. Basically, the ambient temperature requirement as per the EN standard, it is compared 4 temperatures, and the 4 temperature is where the meters are kept for testing, and what is the ambient temperature, what is the temperature of the fluid passing through the meter, and what is the temperature in the reference standard. From the all places, the temperature should be within 2 degrees centigrade, and ambient conditions, variation in ambient condition over a period is 4 degree or 4 Kelvin per 12 hour and 2 Kelvin per hour. But at present, FCRA is capable of maintaining the temperature within 0.5 degree centigrade throughout the test, considering the temperature at the meter, at the reference system, and where it is being stored. Bellprover, one of the best reference standard, which is also covered by the EN standard. We have a Bellprover of 500 liter capacity, and now the claimed BMC is 0.1%. When it was supplied, it was 0.2%, and over that we improved the accuracy by changing the scale from mechanical scale to digital scale, and a better calibration method for determining the volume. The accuracy has been increased from 0.2% to 0.1%. And at the lower range, we have another Bellprover, but accuracy is slightly inferior. It is 0.3%. And to the very low flow rate, we have a piston prover, which is 0.2%, and flow rate can come down to 0.0012 meter per second. And for testing, endurance test and all, we have a small test bench which is developed in FCRA itself. We can accommodate 10 meters in series. And in this one, we can connect Bellprover, or we can connect critical nozzles. So different standards can be connected depending upon the flow rate it is required, and we'll select accordingly. The test bench. For different types of test, like spray systems, different climatics, we have climatic chambers where we can vary the temperature, humidity, etc. For different to generate different climatic conditions, and of course we do some of the tests using these chambers. We have a shaker also. At present, it is showing a scanner, a application, but in the same a smaller shaker is being used for vibration and vibration measurement monitoring system called diaphragm gas meter. This is some one particular result what I want to share, because standard says the accuracy over 6 continuous cycles of operation. So how the error curve that is varying, that can vary, that again will depend upon the manufacturer or model. So 1, 2, 3, 4, 5, 6, you can see that is a particular result what we have observed. Though the pattern, accuracy pattern is different, it is within the acceptable limit. This is very interesting for the manufacturer or developers, how it can vary in, and it will help to select the material of diaphragm and other hinges and other counters. And then we do the torque test. So these are all relatively simple tests. We can have the torque test and bending moment test, resistance to impact. These are all the things we developed in the beginning, because we were also very new to this requirement, and all of a sudden if someone is approached FCRI that we want to have a model approval, that in our country that implementation of standardization has been started. So earlier it was imported, and then our CGD, the pioneers in that field, they will deploy the meters, and over a period of time our nation want to have a tested and validated flow meters, and when they approached, it was defined, everything was developed within our knowledge what is to be done. So every time it is a new challenge for us to devise it and then test it. And the impact of one of the manufacturer who was not there in the present, from the impact test 2 times, this is the 3rd time he could pass that particular test. So that time it was really interesting, and why that test is so important, because many people asked me why that test is very important. So after doing the test, and then initially the manufacturer also could not believe that he is also following some international standard, but due to the type of material he has used, so 2 times his product failed in that particular test. The 3rd time only you can succeed by changing the materials. So this is showing how important a standard is, and the test criteria also, that our manufacturers, users, our law-making agencies, how to make a particular law a standard, and how the manufacturer deal with the standard, and what an end user expect a standard. So without this testing and experience, we will not be able to understand many of the requirement in the standard, whether we should follow it or not. So really it will help us to improve and reach to a higher level. So nowadays our manufacturing units are also looking for export of their products. So from the import side, we are starting to export side. So many of the standards which we are having may be insufficient to the international market, but now by adopting the international well-known standards to India, which is suiting to the Indian conditions, and which will help us, the manufacturers and the testing agencies also, to test it and help the manufacturers to export their units. So I just shared a very small information what FCRI could do and what FCRI was doing. So with that one, I want to conclude my session. So anything regarding FCRI, you can ask me.
Thank you very much, sir. And yeah, you have explained the various test methods that are required in gas meters, and all your studies that you have done to improve the accuracy of equipments, certainty of the equipments there, FCRI. And also you have given an insight that what are the best models for getting the better accuracy in India, and importance of the impact test and top test. Thank you very much for your presentation. And now I will request all the panelists to start the discussions with our attendees. What I will do, I will invite some of the attendees who have raised some questions to discuss, and I will request the panelists to answer their questions. So just whoever wants to directly interact with the panelists and BIS, they can raise their hands, and I will be able to see the raised hands in the list of attendees. Particularly, one request was there from Mr. Sandeep Rastogi, who wants to share few points on cyclic volume and 14439. I will just give you, I will ask you to unmute in a minute. So one question from CV Suresh sir is, please explain rangeability and turn down ratio significance while meter type selection.
Yeah, turn down ratio is the ratio of maximum flow rate to the minimum flow rate a flow meter can measure. Suppose a flow meter is having the range 100 meter cube per hour maximum and 10 meter cube per hour maximum. The turn down ratio is 10. That is a simple ratio of 100 by 10. So that is the turn down ratio. And rangeability of the meter, of course, some participant asked earlier also. The rangeability of the meter, that is the prescribed accuracy, what is the minimum range a meter can measure and the maximum range a meter can measure. But that doesn't mean that every time the meter can run continuously at these extreme ends. It is also not advisable. The best measurement accuracy we can get over the range of about 30 to 70% of the range. So if you are sustaining at the maximum flow rate, the meter healthiness also may deteriorate over a period of time shortly. So you will get the best performance in this range, but minor variation also can be there. And then nowadays the meter is having two different ranges based on the accuracy. That is, someone asked what is the QT, Q transition. That entire measurement range of the meter is divided into two segments. One segment may be a range from Q minimum to a Q transition, and another range from Q transition to Q maximum. So Q transition to Q maximum, you have a better accuracy. And normally for any type of flow meter, if you go for a lower flow rate measurement, then it will have an inferior accuracy. So that is in the another range from QT to Q minimum, you have a higher error value. You can observe a higher error value. So the QT can be from 10% or 20%. Normally manufacturer can fix it, but it is not allowed to fix more than 30% of Q maximum. That is 5 turn down ratio 5. So at least a turn down ratio should 10 should be there to fix the QT.
Thank you, sir. I hope Mr. Raj Singh's.
So one question from my side. Actually, in many of the tenders, we are saying that they are asking for utilities asking for MOP, that maximum operating pressure पे test करने के लिए. So is it really possible on test bench on nozzles, sonic nozzles, that to test a meter on MOP? Yes, sir.
Can you explain? I could not follow you.
So tenders, a few tenders are asking for your meter should be tested on MOP, maximum operating pressure. Design
maximum operating pressure. Okay. It is not that every time we are operating at the maximum operating pressure. That is the designer, manufacturer who designs a flow meter which can capable of handling that pressure. So maximum operating pressure will be selected in such a way that normally we operate the pressure at a lower pressure. and at a shorter period you can go for a higher pressure. Okay, so even in that pressure, the meter is capable of metering to that accuracy. Above that pressure also meter may function, but accuracy may not be guaranteed, or performance of the meter may be deteriorated either in the negative way or in the positive way, we do not know. So maximum operating pressure test is possible if you operate every time at the maximum operating condition. As far as the standards, the general practice is that what is your operating condition, the calibration should be done close to the operating condition. It is not always that if you are a flow
Exactly,
meter
exactly.
capable of 20, taking 20 bar when you are operating at 9 bar or 10 bar, it doesn't make a good sense that you have to calibrate at 20 bar and use that result to your operating condition. So try to perform the calibration at the operating condition, but again depend upon the type of fluid you are handling, the operating pressure or the operating temperature. Many times you may not get a laboratory who can use your operating fluid or operating condition. So there are many other criteria where a flow meter can be calibrated with another from operating condition to a calibration condition. So that very depend upon the type of principle of operation.
Thank you so much, sir. Thank you.
That's it. So one question in particular has been asked by many of the attendees, and I would like to all the panelists to give their insights on this. The question is, can technology upgrade from diaphragm meters to ultrasonic be adopted in India? It is a basic question, and I think it is a decision that has to be taken by regulators, but I would request the panelists present today to give their insight on this. So particularly Vyas sir, this has been asked from you, so you can start with your insight into this.
I think the regulators actually does not prohibit any technology. So as far as this particular question is concerned, yes, of course, we know that in domestic, mostly diaphragm meters are used, but there are people who are coming up with meters with other technologies. So whatever technology is being used, there are standards for that particular technology. And if the meter is meeting the requirements for those standards, I think it can be used.
Right, sir. Kaushik sir, what is your view on this?
Yeah, actually, what I think is I'm in line with Vyasji. So he is absolutely correct that that is a complete choice of a utility, obviously. And the measuring method of diaphragm, the basic difference between that is we are measuring volume of the gas directly by a diaphragm meter, whereas we are measuring by a calculation meter indirectly in ultrasonic or turbine meter. This is the basic difference between that. We are flow is measured indirectly in thermal or ultrasonic, whereas in gas meters, diaphragm meters, volume is directly measured. That is the main difference, and choice is up to the utility. And rest, obviously, you have to go with the standards accordingly. There are different standards for different kind of meters. So it's absolutely choice of the utility. Go with. This is the difference. Yeah.
Right, sir. Patranjan sir, would you like to add anything into this?
I think the question has been perfectly answered by both of them. Different technologies have different measurement methods. As Mr. Kaushik just mentioned, volume is measured by diaphragm meter, thermal mass flow, and thermal mass flow actually measures the mass. So ultrasonic measures based on usage of sound. So that's something indirectly, which is indirectly measured in that case. But ultimately, yeah, the meters which are made for an application tested based on a relevant standard. If there is a standard of ultrasonic meter and the meter has been tested, definitely it can be used. I mean, there is absolutely no reason it cannot be used.
Right, sir. Okay. So some of the attendees have raised their hands. I will try to unmute them. You can ask your questions.
Sir, I want to supplement something regarding this question. Choice of
sorry, sir. Yes,
technology.
sir. Please.
The choice of technology is ultimately the cost of maintaining a particular technology. What is the initial investment cost? What is the operating cost? And what is the recalibration, re-verification cost? So over a period of 2 years, say 5 years or 3 years or 4 years, what is your overall cost? Ultimately, that is the deciding factor. Model approval test or calibration can be done a particular technology very easily. But in considering the initial cost, how much is the initial cost for a CGD? And what is the recurring cost, what is the revenue margin, so and what is the volume of number of meters required, what is the geographical conditions, what is the educational level of people. So many things depend upon in selecting a particular technology which is to a particular nation. It is not like that a European developed nation is using the technology, it can be immediately adopted in our country, or whatever technology in our country can be implemented in another country. It's very difficult to answer, but that ultimately the successful selection of a technology depend on various factors. So we have to consider all the factors and then selecting a proper technology which is optimum suitable to that particular country or region of the country.
Right, sir. So, Mr. Akhil Dal, you have raised your hands.
Yeah. So I would like to understand that in the looking into the Indian terms and conditions, what is the maximum or average usage of the gas in a period of let's say if in India the gas meter has been installed in the last 15 to 20 years. So what is the average consumption? Can we have the view on that?
So, Suresh sir, did you get the question? Would you like to answer that?
But I don't have the current information of this.
Actually, what exactly the question, what I understand is if you are asking that currently monthly billing or something like that, or the current average consumption per consumer or something. Get he's
I
asking
think what
that.
he is asking is how much gas is being used in India. I also don't remember exactly, but I
Actually,
believe
what I have
these
seen,
data
if I
are being
consider,
published by Natural Gas Society. If somebody looks at the website of Natural Gas Society, they publish how much gas is being used, imported, and all. Some of the useful data are being published. So I'm not sure, but maybe this will help Mr. Akhil to answer get answer.
No, I would like to understand what is the average gas consumption in a household, like in a per
okay,
on a
okay,
period of
got it,
15
got it.
years.
Yes, I think normally utility raise a monthly or bi-monthly bill, and what I have seen in average, it depends on from anything between 15 SCM to 35 SCM, depends on the family structure, family size, and all. This depends actually the consumption, how many people are there in a family, and here gas is only used for cooking purpose only. So this absolutely depending on the family structure or family number of members in a particular family. So what I have seen in average is 15 to maybe 35, 40. This is maximum I've seen that.
Oh,
Thank you.
now I will request Mr. Anand Langalia. You can unmute yourself and ask your question.
From Enel Gas Controls and Enel Gas Metering Systems Private Limited. So my question is that I understand that in domestic gas, where the pressure is very low, conversion to standard meter cube per hour is not required because the pressure is close to atmospheric pressure. But nowadays in India, across various states, the at least in the commercial segment, where the gas is supplied by the CGD to different commercial restaurants or hotels. So that gas is currently supplied at a higher pressure, and due to which I believe what currently the utilities are doing, they're applying a fixed factor, and a lot of times I would say that it is not a method of transparent billing to the Indian users. Let's say the pressure is the supply pressure is low, and the factor that is applied is the lockup pressure of the regulator. So it is, I would say that in a way, justice or transparent billing is not happening. So I would just like your opinion if at least in the commercial sector, the correction should be made mandatory, or let's say billing should happen in SCM.
Well, Mr. Anand, well, technically, what you raised is right, but I will slightly differ with not transparent, because yes, we all know that the volume is dependent on temperature and pressure.
And just to add to it, sorry for interrupting you, we have seen a lot of case studies in many different utilities that there is a lot of tampering happening on the regulator itself. And customers are tampering with the pressure that the gas is supplied at, in which there is a loss to utility as well.
Right, tampering is different. I think you have raised two different questions. One is related to tampering, and another is related to measurement of volume at actual temperature and pressure. So if we are not using the actual temperature and pressure being supplied at the point of supply, then obviously the measurement may not be as accurate. Means there is additional uncertainties which are added to the volume measurement being measured by the meter, and hence this is transferred to the billing also. This uncertainty is there in the billing also. And I think there are volume correctors, which some people call EVC, electronic volume correctors, which can be used along with the gas meters to reduce these uncertainty. So yes, I agree with that, but I will not say this is not transparent, because the consumer knows that his billing is being done from the emitter without the correction. But yes, you are right. The uncertainties in those billings are high, because actual temperature and pressure are not being measured, and hence no correction is being applied for that, or maybe an average correction is being applied for that.
Okay, sir. Thank you.
Okay. So I think most of the questions has been answered, and if there are any more questions related to standardization and the changes in the Indian standards on gas meters, you can write your queries at pgd@bis.gov.in. We also monitor the committee email, that is pgd26@bis.gov.in, if you want to talk about weights and measures in particular. If there are any more questions or somebody would like to talk to the panelists, you can raise your hands. I will give 1 more minute, and then we will end this webinar. Okay, so since there are no questions, at the end of this webinar, when you leave the webinar page, you will receive a feedback question. There also you can mention the questions. We will try to resolve all the queries through emails also. So with this, now I would like to propose a sincere vote of thanks to all the speakers, organizers, and the participants. So first of all, I would like to thank our esteemed speakers, Sri B.M. Vyas, Sri Kaushik Paitandi, Sri Patranjan Bhattacharya, Sri C.B. Suresh, and Sri M.K. Nayak for sharing their knowledge and expertise with us. Your insightful presentations have truly enriched our understanding on the subject. I would also extend my heartfelt thanks to our DDG Standardization Sri Sanjay Pant, for his inspiring inaugural address. Sir, your presence has been a great source of motivation for all of us. I would express my gratitude to Head of Production and General Engineering Department, Sri Rajiv Ranjan Singh, for his support in making this event possible. Finally, I would like to thank all the members of Weights and Measures Sectional Committee PGD 26 and my colleagues from BIS for their valuable contribution towards the success of this webinar. I hope that the knowledge and insight gained from this webinar will be useful for the participants in their respective fields. Thank you all once again, and have a good day. For any further queries, you can write to pgd26@bis.gov.in. So with that, thank you all and have a good day.
Thank you. Thank you.
Thank
Thank you
you.
so
Thank
much.
you very
Yeah.
much.
Thank you.